Hello, and welcome to our webinar on harnessing the power of your 8800 controller for new users. My name is Mark Pike, and I'm the Marketing Manager at Thermotron. And our presenter today is Chris Golton, a Sales Manager at Thermotron and an expert on the 8800 controller. We are very excited to have you, and we hope that you enjoyed today's webinar. Before we get started, I wanted to let you know that we will be muting everybody on the call during the webinar, but we will still be taking questions. So if you have any questions throughout the webinar, just send them directly to the organizer, Jane Newton, through the chat window that can be found in the GoToWebinar panel. At the end of the presentation, Chris will be taking some of these questions that have been submitted. Well, let's get started. I'm going to hand it off to you, Chris. Thank you.
Thanks, Mark. So just to give you an idea of what we're going to be doing today, every spring here in Holland, Michigan, we have a service seminar, and I teach a course on the 8800, and it's about 2.5, 3 hours long. And we're going to condense that down and kind of hit the high points of it here today. So today we're going to do kind of the basic stuff, give you a real good feel on how to run a test and get results out of the controller. And then next week we're going to dive a little bit deeper into some of the more advanced settings and setups. And if you haven't already done so, when you signed up for the webinar, you did have the opportunity to download a demo version of the 8800. And the intent there is so you can use a split screen and follow along, or install that on a separate computer. And it only takes about 30 seconds to do that. So if you haven't done that already, feel free to do so. The other real nice part of that demo software is it really is a full functioning controller. So we have customers write programs on that demo version at their desk, load those programs onto a flash drive, and then you can bring it around to your different chambers and load them on that way. And then it's also nice just for training purposes, practice purposes, and so on. So just again, basic stuff today. Next week, we're going to do the more advanced stuff. And if you haven't already signed up for that, I think it's about 60% full. So if you intend on doing that, do so soon. And if you can't make it next week, we are going to record both of these sessions so you can come back and go through them anytime. So just a little background on controllers. So what we're going to be going through today is the 8800 controller. It's our top-of-the-line, flagship, most powerful controller. And we install it on all of our, I'll say, big, expensive equipment. We also have two other controllers, one being a 3200 that we install on our benchtop units and some of our medical equipment. And the key thing there is it's a basic, inexpensive controller. And a lot of these benchtop units, they are $7,000, $8,000, $9,000, $10,000. And we need an inexpensive controller to go on those units. A 8800 controller in itself is $6,000, $7,000, so we really can't put a $6,000 controller on a $7,000 chamber and still be competitive. So the reason we have multiple controller lines is mostly due to cost and then also some sizing constraints. And then in between the 3200 controller and the 8800 controller, we have an 8200 controller, and we put that on our what we call an S-series line. So like if you have a SM8, it will have an 8200 controller on it. And all of the stuff we're going through today is the same function on the 8200 controller. So the 8200 and the 88 are very, very similar. So if you only have 8200 controllers, you'll see this and kind of feel right at home. So they're very, very similar. So just to get started, I want to show you a little bit on the hardware end of things. Okay, so the first part of the 8800 is the touch screen, and if you have one of these, you're definitely familiar with it. So this is a 12-inch touch screen. This is where you input all the data. You can see what test is running. And this is tied into what we call a single board computer or an SBC. And this photo here is just of the inputs that you can use into that single board computer. So there you see a couple of USB outputs. Those are most commonly used for downloading data to a flash drive so that you can load that onto a computer and graph it out or see that information. And then you also see an Ethernet port there. That's for plugging different controllers or different chambers into a network so you can monitor them, control them remotely. And then you also see a serial port there. So instead of Ethernet, you can also use serial or RS-232. And then the other ports you see there are just to tie into the touchscreen. And then the other part of an 8800 that you quite often don't see is what we call the control module. And what this is kind of the brains of the operation, if you will. So very similar in function to a standard controller, if you will. It's got a lot of relays, inputs and outputs that we've designed and built specifically for environmental chambers. So it's got a lot of thermocouple inputs, different inputs and outputs to turn things on and off. So as an example, later on when we turn a light on in the controller, what actually happens is that signal sent from the user interface on the software goes to that SBC. The SBC sends a signal to the control module that you see here, and one of these relays will close that's wired into the light and turns on the light. Okay, so you should see the 8800 on your screen. What we're going to do is just walk through some of the different screens, give you an idea how to run it, and then some of the key features you can use to in your own testing. So the screen you see right here is accessed by touching or clicking on the main icon in the upper right. And what you have here is the different channels that your chamber will have. So in this case, this is a temperature and humidity chamber. So you have a temperature and humidity channel. Our controllers have 4 different channels that you can use depending on the type of chamber. So if you have an altitude system, it would also have a altitude channel up here, and so on. On each of these channels, you'll see the name of the channel. So here's air temperature. You'll see the set point. That's the condition that we want to go to, and we'll be changing set points here in a moment. And then the other thing you'll see here for each channel is the throttle. And what throttle is just how hard the system is running. So in the case of air temperature or a temperature channel, a positive throttle would mean that the heaters are on. A negative throttle would mean that the compressors are on. And it'll be a function of the full capacity. So in the case of heat, if you have a chamber with 10,000 watts of heat and you see a 50% throttle, it just means that there's 5,000 watts of heat on. So if you're following along, go ahead and select the manual icon, and that'll bring us into the manual test screen. And what this is if you're manually changing set points as opposed to running a automated profile. So the way this works is you would select the channel that you want to change. So in this case, we're going to change the temperature. And I'm just going to pick a -40 set point. And you select Run. And what you'll see is the set point instantly will go to -40. The throttle comes on, and here you see it's -100%. So what this means is our current temperature is 58. Our set point is quite a ways away from 58, -40. So the compressors are going to come on 100% or as hard as they possibly can. So to change a set point, we just, if it's a touch screen, you would touch the new set point, put in that temperature, and you'll see a little dialog box comes up here. Your settings have changed. Press Run to commit the changes. So basically, this set point is on deck waiting for you to send it to the controller. So as soon as we press Run again, you'll see the set point change to 85, and then the chamber would try to go there. So now we have a throttle of 100%, meaning the compressors have now just shut off and the heaters have come on. And it's the same way with other channels, whether it's humidity, product temp control, altitude. You just put in the set point that you want and press run, and it will accept that new value. So down below here are different options for this particular chamber. So right now you see we have humidity turned on. So if we wanted to turn humidity off, we would just unselect that, and now you can see there's no longer any humidity control. If we wanted to turn on product temp control, we simply just select that option. And for those of you unfamiliar with product temp control, I'm going to show you a graphic of the differences between the two. So here's a graphic, and this is just a quick test that I went out in our lab and ran. So I put a small part in the chamber, attached a thermocouple to it, and ran two different temperatures, 100 and then back down to ambient. So what you see in red is the air temperature. So you see that it went from ambient up to 100 degrees C. And then the product, because it has some mass to it, is going to change at a slower temperature than the air. So in this case, you see that the air temperature got there in roughly 10 minutes, and then the product got there in about a half an hour. So real typical for testing, the product is always going to lag behind the air. If you have a real big, massive product, if we were testing a bowling ball or an engine block, that could take several hours for that somewhat cool product to get up to temperature. So this is real conventional. This is how most of our customers certainly start off testing, and a lot of the test specs are written this way. Now, product temp control, on the other hand, controls everything based off of the product. And so here's the same test, ambient to 100 degrees C, but controlling off of the product. And one of the things you'll see is the product actually got to set point much quicker. In this case, about half the amount of time. So instead of a half an hour, it reached its desired set point in about half that time. And the reason for that is when we're using product temp control, the air temperature will overshoot the set point by an amount that you can select in the setup to get the product there quicker. So in this case, I set it up for 10 degrees offset. So you can see that the air temperature actually went up to 110 degrees, which will drive the product up there quicker. And there's really two nice things that this does for you. One is it really ensures that the critical part of your product gets to temperature, and it can also reduce the total amount of test time. A lot of your specifications are often written around a dwell to allow the product to get to temperature, and a lot of times it's just a guess. So you might have a 1 hour dwell just to allow the product to get there, where with product temp control, you kind of take the guesswork out of that, and you can ensure the product temperature surface gets there. So back to the controller. One of the options you also see on here is a purge, and this might be a dry air purge or a GN2 purge. And when we turn this on, if your system has it, it'll start purging air or gaseous nitrogen into the chamber, and that's used to reduce moisture in the chamber while you're thermal cycling. So if you have a product that's powered up and condensation could cause a short or some other type of failure, you can purge during thermal cycling to make sure it's real dry in there and to prevent any condensation on the product. Next to that, you'll see the refrigeration mode. And the important thing here is when you're running manual mode or even tests, just to make sure that this is set to a cooling mode like cascade, single stage, or power save. One of the frequent calls we get into tech support is, hey, my chamber was working fine yesterday, now it's not cooling. and one of the first things they'll ask you is, hey, go into the refrige mode, just make sure somebody has inadvertently selected no cooling, which disables the refrigeration system. The thing you'll see next to that is the auxiliaries, and what those are auxiliary relays that you can use to turn your product on and off. So if you're testing light bulbs, you want to find out if they come on at -40, you can put in a set point of -40. Once it gets down there, you could turn on one of these aux relays, press run. The relay on the control module that I just showed you will close, and then that light bulb could come on. So you could do a cold start for that. So that's kind of the basics of manual mode. Just some of the other icons we have along the top here. Right now we're in run mode, and you can also see that down in the bottom corner just what mode it's in. We're in manual mode, and then the run icon is lit up. So if we press stop, which will stop the chamber, and we'll say yes to that, now the stop button is lit up. And that just tells you when you walk up to a chamber, it's one quick way to tell if a test is running or not. Because a lot of times they're very quiet, you can't hear if they're running, so that instantly tells you whether it's in stop or run mode, and then you can also see the same thing down here. The mode is now stop. Some of the other icons you have up there, there's a hold. So if you're in the middle of a test and you want to pause it, you can press that hold, and that'll just pause the test. We'll touch on some of these features a little bit later. There's a light icon that just obviously turns the light on and off. There's a access icon, and these are different access levels, and you can use these to lock out certain functions to certain users. We have a lot of customers that use these in a production setting where maybe the engineer or test manager will set up the test, and then production people will go in and just simply place a part in, shut the door, and press run. And you want to make sure that nobody goes in and changes any settings or programs. So with this feature, we can set it to a certain access level to ensure that nobody can change any critical settings. And in the manual, there's a full description on what each one of those access levels can lock out. And then from the factory, we don't put in a password, so anytime you want to change one of these, you don't have to put in a password. If you want to change the password, you can select that, and it'll prompt you to change it. So if you ever go up to your controller and you see that things are grayed out or look like they're non-functioning, chances are somebody's changed the access level and locked those out. So you can just go back into Programmer or Lab Manager, and that gives you access to all those functions again. Okay, so that's manual mode. Now we're going to go into program mode and walk through on how to write a simple program. So to do that, you'll select the program icon, brings you into the program screen. And first I'll stop the chamber before we start writing a program. Certainly not necessary. You can write programs as other programs are running, and it won't affect anything. So I'm going to show you an example of a program. So here's one, and this is either a UL or IEC program. It's called a thermal cycling profile that's used in the solar industry. This one just happens to be. So if you read this spec, it's the module is subjected to cycling temperature limits of -40 ±2 and 85 ±2. So you can see here we start at 25, ramp down to -40, stay there for 10 minutes, ramp up to 85, stay there for 10, go back down to -40, and then this cycle repeats itself 200 times. So we're going to go back to the controller and show you how to program it. And what I like to do before I write a test is just, I'll grab a piece of paper and kind of sketch out how many steps this is. So I'll say, okay, this is going to be step 1, 2, 3, 4, 5 steps in this profile. So it should be about a 5-cycle test. And I like to just sketch it out so I know what it's supposed to look like. So once we run it, we can kind of double check it. The other thing to make note of here is there's a ramp rate specified. And this particular test just specifies 100 degrees C per hour max, which is 1.6 degrees C per minute. And that's specified here as a maximum change rate. A little bit unusual to specify a maximum change rate. Usually it's specified as a minimum change rate. So we'll switch back to the controller and go ahead and program this. So the first step, down in the lower left, there's a icon to start a new program. So you select new, and you'll see up here it's now an untitled or a new program. So the profile specified starting at an ambient temperature, which is 25, and a final temperature of -40. So we're going to program in that first. And then there was a ramp rate of 100 degrees C per hour or 1.6 degrees C per minute. So we'll put in our ramp rate here. So we're about halfway there. There's a couple of key items from that test profile I want to point out that drastically can change the way we write the profile. So first of all, this is a program based on air temperature. So we're going to write it with air temperature rather than product temp control. The other thing that's specified here is it's -40 plus or -2. So take note of that tolerance. And then take note of this dwell time. It's a minimum dwell of 10 minutes. So those two things are key. So we'll go back to the controller, and I'll show you what we do with those. For the tolerance, we're going to put the tolerance in here where it says deviation, and I'll explain that in a moment. So our tolerance was 2 degrees or plus or -2. And so we've got our start temperature, our end temperature, our tolerance in there, and this 1.6 degrees C per minute comes out to 40 minutes and 37 seconds. So this step is all taken care of. We want to make sure we've got cooling selected. We already said we're not going to do PTC. And when we're done with this step, we'll select Insert. And now we're on interval 2 of 2. So the second step was to dwell at -40 for 10 minutes. So we've got our initial value of -40, and you can tell that's grayed out, and that just means we can't change the initial value anymore because the initial value of steps 2 through infinity are always the final step from the previous interval. So we want our final value to be -40 because this is a dwell. So we're going to start at -40, end at -40. We're not going to be ramping, but we want to hold for 10 minutes. And this is where the tolerance comes in. So there's a function here called GSOAK, and that stands for Guaranteed Soak. And if we select that, what happens now is the chamber is going to ramp down over the course of, this is step 1, 40 minutes, 37 seconds. And then it's going to move on to step 2. And what it's going to do is it's going to check to see if it's within tolerance, in this case within 2 degrees. So if it has reached -38 or within 2 degrees of -40, it will start the 10-minute countdown. If it hasn't, it will hold the ramp until it gets there. And then once it's within tolerance, then it will continue on with that 10-minute dwell time. If we don't have GSOAK selected and this tolerance gone, then what it's going to do is it'll ramp 40 minutes, 37 seconds, and immediately start this 10-minute step regardless of it's at temperature or not. So if you have a big, heavy, massive product in there, or you have a chamber with really small compressors, it might take 2 hours to ramp from ambient to -40. and in that case you would never really reach the desired set point. So what guaranteed soak really does for you is guarantees that you meet that ±2 spec for the full amount of time that this spec calls for. So I like to call it, with guaranteed soak, it really changes it from a time-based profile into a temperature-based profile. All right, so that's step 2. To go on to step 3, we'll select insert. Our next step is to go up to 85 degrees C. We can remove that tolerance. It really doesn't apply here, so I'll just leave it. Our ramp rate, again, is 1.6 degrees C per minute. So that's going to take 1 hour, 18 minutes, 7 seconds. So we double check it, -40 plus 85 at 1.6 C per minute. So we're good. So I'll select insert. And then according to the spec, we have to be at 85 ±2 for 10 minutes. So we'll put in the 10 minutes, select that guaranteed soak again to ensure that we're there, and select insert. So after that hot dwell, we're going to go back down to -40. And in this case, we're going to be doing a looping program because I told you we have to do it for 300 steps. So we're just going to go back to the beginning or back to 25 and loop this over and over again. So my final temperature will be 25, so 85 to 25. And at the end of this, what we wanted to do is not continue on to a next step, but we want to go back to the beginning. So we have 200 cycles of this. So the way we do that is we're at 85. When it gets to 25, we want to loop back to step 1. So instead of the next interval being 6, we're going to make that 1, and we're going to have 200 loops. And that's 200 total loops, including the one we just wrote. So what will happen, this will run 200 times. At the end of it, so the very last interval will be from 85 to 25, and then at the end of the program, the chamber just stops. So if you wanted to soak at ambient to get the product back cooled down, we could put in one final step to hold that ambient for 25 minutes. And now at the end of those 200 cycles, it would stay at 25 for 25 minutes and then shut off. And then at the same time, we could even use one of these auxiliary relays to trigger a end-of-light test or a beacon of some sort, an alarm, just to let the user know that the test is over and they can unload product. So just another use of auxiliary relays. Okay, so we've got the program written. You can see it up here graphically. It kind of looks just like that spec did. So it starts at 25, goes down to -40, stays there. So it looks right. And we can even look at the entire test, all of the loops, by selecting the loops icon, and that would show the entire test, all 200 cycles. Okay, so we're done with the program. Now we want to save it. So to do that, you go up to the Save As icon, and you'll see it's going to be a PGM file, which is just the extension we've given it for a 8800 program. So I'll call this thermal cycling test, or TC, and we save it, and now that test is saved to the hard drive. So we've written the test, we've double-checked it, make sure it looks right. Now we want it. So to run a program, you just simply select Run, and as soon as you do that, this Run Options comes up, and we select the profile. So here's all the tests we have on the 8800 controller. So we'll select the one that we want to run and pick Select. And you'll see a couple of other options here. One is you can start at a different interval. And where you might use this is if you're in the middle of running a program, you have to stop it for some reason. You stop it at interval 5. And you want to continue on running from there, you could simply just start halfway through a program. The other option you have here is there's a enable delayed start. And what you can use this for is if you have a 6-hour program and you want it just finishing up when first shift comes in tomorrow, you can have it start at 2 a.m. and once you hit run, it won't actually start running the chamber, but it'll start that timer, and once it hits 2 a.m., then it'll start running the test, and that way it'll be finishing up as people come in the morning. So you select run, and as soon as you hit run, it brings you to this interval status screen, and this is just the status of the program we're running. So you'll see here we're at interval 1 right now. This is a 40-minute, 37-second step. Here's the time left, and when it's done with this, it'll move on to step 2. And you can see there's 199 loops left because we programmed in 200. And this time bar will come in to tell you approximately how long the test is going to take. So in this case, 462 hours, 50 minutes, and so on. Now, we don't really know exactly how long it'll take for this program because it's a temperature-based program, or we use the guaranteed soak. So without the guaranteed soak, we know exactly how long it's going to take. In this case, we don't know exactly, but this will give you an approximation. So that's how you write a program and run a program. The 8800 controller has a huge hard drive on it. If you have older controllers, you're used to having to juggle different programs because of limited space, whereas with the 8800, there's a huge hard drive, and you can write as many programs as you want. So the other thing I'd like to quickly show you is this is how to walk through a program just step by step. There's also a programming wizard in here. So if you go several months without writing a program, you kind of forgot how to do it, there's a wizard software that will walk you through the creation of a profile step by step, and it'll ask you questions. Do you want a humidity channel, yes or no? Do you want PTC? It'll just kind of take you through baby steps, and kind of a nice way to ensure that you don't make any mistakes, especially if you're not used to writing programs. All right, so we've run in manual mode. We've run in program mode. So we've run our test. Now we want to make sure that the test has run successfully and take data and put it into a lab report. So I know just based on people raising their hand at service seminar during this course, you know, how many people still use a chart recorder? It's right around 10% these days. You know, a decade or two ago, almost everybody had a chart recorder, and it's largely been replaced by a built-in recorder in the controller, and you can access that with this graph icon. So I just selected the graph icon. Here's a sample test that we've previously run. And what this is the temperature and humidity for this particular test. So this data is always recorded to the 8800 hard drive anytime the chamber is powered up. So if you have a chamber out in the lab right now and it has power to it, it's recording all of the channels that controller has. And there's a lot of nice functionality to this. You can zoom in on different data points. So if you want to see how much overshoot you have, you just touch a spot above where you want to see, drag a window around it, and you can zoom right in on that particular data. To zoom back out, you just press restore, and it brings you right back to where you were. So all of this data is always being recorded in the controller, and you can turn different channels on and off. So you see here we have temperature, and then humidity is up here, and you can tell which color is which by this legend down here. So red is air temperature, green is air temperature SP, which is set point, and then you also have humidity, PV or process variable, and then humidity set point. So if this were a temperature only test and that's all we wanted to see for our lab report, we would go into setup and select process variable, and then you could just simply turn off the humidity. So now we just have the temperature channels shown. You can zoom in on that. So if this is what we wanted to produce for the lab report, we zoom in on it, and you can print it to a local printer. So you would do that by plugging it into either the Ethernet port or one of the USB ports. Or you can save the data to a thumb drive. So you would select Save As, and then you can save it either as a CSV file, which you can import into Excel, or you can save it as a picture or a bitmap. So if you're putting together a report in Word, you wanted to insert a picture, you would just simply save this graph as a bitmap, and then you could insert that into a PowerPoint or Word document. A couple of other things on the graph screen. You see here, you can change the background color, your line colors. There's a function here where you can turn a bar on or flags on or both. And what that does is at the bottom, it'll show you in green or red whether the chamber was running or not. And then it'll also put a flag at the beginning and ending of each test. So if we started a test here, it ended here, it tells exactly what program was running and when it stopped. And that's useful to go back into the data, see what program you ran, and then also if you want to export the data, it gives you a timestamp at the beginning and the ending as well. So that's the graph screen. One of the other icons over here is the thermal arm. And what the thermal arm is a over temperature, under temperature protection device that's intended for you to use to protect your product. And years ago we called it the product saver, which is something a little more descriptive. And if you have especially if you have an expensive product that could be destroyed by either hot temperatures or cold temperatures, it's a good idea to set this up at those limits. So if you have a chamber runaway, it'll shut things down and prevent one of those situations from happening. It also has contacts on it, so you can wire those into your product and shut down your product as well, so that you don't have a product that's continuing to give off heat inside of the chamber and continue to heat things up. One of the last things I want to show you today is another feature of the 8800 that's optional, and it's called a DAC, or Data Acquisition System. And what this is a separate box that has either thermocouples, analog inputs and outputs, and digital inputs and outputs. And there's different configurations of these. And we just have a lot of customers that either want to add in additional thermocouples to their controller. This is a simple way to do it. Or a lot of times you're running an electrical product and you want to monitor certain variables for your product. So if you're testing back to the light bulb example, if you want to monitor the voltage going through the light bulb so you can sense when it failed, you could simply wire in an analog input or voltage input into one of these analog inputs, and it would track those variables right along with the temperature and humidity and product temperature. And that's accessed right in the software here. So here would be the thermocouples you would set up. Here would be the analog inputs and outputs that you would set up. And we'll spend a little bit of time next week going through how you would set these up. So that gives you kind of a basic overview of just how to run a manual test, write a program, and then take that information out of the controller and put it into a useful lab report. And then next week, what we're going to do is get a little bit deeper into some of the setup parameters and some of the setup to the controller for some more unique situations.
All right. Well, thank you so much, Chris. Great job. Really appreciated the information you presented. And I want to reiterate, if you have any questions, feel free to send them through the chat window through Jay Newton, the organizer, and we'll be able to get some of those answered today. And I also just want to clarify that the webinar is, in fact, in 2 weeks. So it's going to be on March 23rd, Wednesday at 11 a.m. Eastern Time. And, of course, more information about that webinar can be found on thermotron.com. And like Chris mentioned at the beginning of the webinar, if you haven't signed up, please do so already. Spots are filling up, and we will have to cap it at a certain limit. So please make sure if you have interest in that to go ahead and attend. And just want to reiterate that we will have both this webinar and the webinar in 2 weeks. They will be recorded, and they will be available on the website as well. So if you can't make it or you can't register, we will make that available so that you can spend some time watching the webinar and then working on your system side by side as well. All right. Well, and also if you have any additional questions, or want to learn more about Thermotron, feel free to contact us at info@thermotron.com or call us at 616-393-4580 and visit our website. Chris is reviewing some questions right now, so I don't know, Chris, are you ready to answer a few of these?
I'm ready.
All right, perfect. Well, here we go.
All right, so the first question we have is how do you use ramp rates or other tools to reduce the peaks and valleys that occur as the system works to maintain temperature and humidity? And those settings are something we'll cover in the next session, and it gets into the PID settings, and it's really gets into the algorithms that the chamber uses during ramps and changes in temperature. So we'll certainly cover that next session. And it's a fairly basic thing to adjust once you understand what they do. So we'll certainly cover those. The other question is, can you control the 8800 remotely? And you can certainly do that, and there's several different ways of doing it. If you just want the status of the controller, we have a built-in web server. So if you go into the computer interface settings, you'll see an IP address for the controller. And if you plug that IP address into a computer that's on your network, a status screen will come up showing what the controller is doing. And on the screen right now, you can see what that would look like. So you see the IP address up here, and this is just in Internet Explorer. And as soon as you do that, the chamber would come up and give you a status of current temperature and then where you're at in the profile. So that's simply a status. If you want to control it remotely, there's two ways to do that. If it's just an 8800 controller or you have a room full of 8800 controllers, the best way to do that is using something called VNC, which I think is Virtual Network Computing. And we've pre-installed that on the 8800, and you can download that, and it's a shareware, and load that onto your computer, and then going through that same process of the IP address, you would just simply log in, set up the controller to be controlled remotely, and then you could sit at home on a Saturday and write programs, start and stop the chamber. We have a customer with a lot of systems overseas, and all their chamber experts are in the United States. So what they'll do is log into several chambers and just check on pressures, temperatures, things like that to make sure everything's running properly. Another question we got, how does ramp rate work in manual control? And I'll quickly show you that. So just like in programming, you can set the ramp rate. So in this case, if we're at -40 and we want to ramp to 0, we would put in the new set point and our ramp rate, and in this case I'll just do 5 degrees C per minute, and this is C per minute. And if you remember before, as soon as we hit run, the set point would go to that temperature. Now that we've put in the ramp rate, what will happen is this set point is going to ramp at 5 degrees C per minute. And then the chamber will try to match what that set point is. And the same thing going in any other direction. Now if we go 100 degrees C at that 5 degrees C set point, happens the same way. All right, the next question, can the aux relays be set to turn on automatically at a certain temp? And absolutely. So when you're writing a program, let me just bring that back up. During any one of these steps, you can turn on those aux relays. So if we wanted to try a cold start of the product, we would ramp down to -40, and then during the -40 interval, we would just simply turn on one of these aux relays. And now, during the first step, it won't be on. Once it gets to this interval, it would turn on, and then during the next interval, it would turn back off. And then if you wanted to do just a cycling of the product at a certain temperature, you could break that 10 minutes up into 10 different steps or 20 different steps and just turn that product on and off at different intervals. So just a few more questions. You can also connect to a network printer. Yes, you certainly can. And for this printer, and I'll go through that in a couple of weeks on how to set up a network printer. But there's a way to do that. You just plug the chamber into an Ethernet, and then you could select one of those remote printers. Another question, and it's a good one that comes up quite frequently. In the example, when the deviation is 2 degrees C and the time starts when the temp is at -38, what happens if the temp gets colder than -42? Does the time stop? And the simple answer is no. Once it's got into the control band or the temperature set point band, that timer, in the case of our program, that 10-minute timer will just start and continue on. Now, if that's not what you desire and you want the chamber to pause or stop or alarm, if it goes out of tolerance, there's a way to do that. And that's found under Setup, and it's not in the demo software. But in our newer versions, there's something called alerts, and that could be set up. So if your current controller doesn't have it, our software is really easy to update. It's free. You just go onto our website, and then under service, you'll find a spot where you can update the version of the controller. Where would you find the IP address of the controller? So where you find that is under System Info. I take that back. It's under Setup and Computer Networking. So you would find the IP address right there. So again, if you wanted to just see a status of the 8800, you would simply type this IP address into an internet browser, and if the chamber's on the network, that status screen should show up. Yeah, so one other question, can you set up a time at which the chamber will start? So the sample is at temperature when we come in the morning. Yes, and that's done anytime you run a program you can enable delayed start at any time that you want. So you know the product takes about 8 hours to get to temperature, and you come in at 9 in the morning, you would simply start this test for tonight at 1 a.m., which I guess would actually be tomorrow. So now this will actually start at 1 a.m.
Okay, well that sounds great. I appreciate showing all this, Chris, and making time for us to show this 8800 controller webinar. And just want to reiterate that we will be having another webinar here in 2 weeks, the more advanced version for users. And the information is right here. So it's going to be on Wednesday, March 23rd at 11 a.m. Eastern Time. So if you haven't signed up already, please do so at thermotron.com, 8800 webinar. And just want to reiterate that we will have these webinars recordings available to everybody on our website, and we'll also send out an email to anybody who attended at these events as well. So you will be getting an email with this information. So on behalf of everybody at Thermotron, we want to thank you for attending and spending some time with us. And hopefully this was informative. You guys learned how to use the 8800 controller a little bit better than you knew when you first started this webinar. So thank you much.